everyone, welcome to day 22 of Leetcode My Challenge. Today we have question number 647, palindromic substrings. In this question they have given us a string S and we have to return the number of palindromic substrings in it. A string is a palindrome when it reads the same backward as forward. A substring is a continuous sequence of characters within the string. Example 1, they have given us the input as A, B and C and we have to find the palindromic substring. So the three palindromic substrings possible in this case are A, B and C respectively. Every single character is a palindromic substring. So these are the three palindromic substring possible from this string. Example 2, A. The 6 palindromic substrings are all these characters alone are the palindromic substrings. So 3 this and then A is a palindromic substrings. Like this A is a palindromic substrings and this A is a palindromic substring and this triple A is also a palindromic substring because we read either from the forward or in the backward direction it will be same. So that's why the output is 6. So if we have to find the palindromic substring in this, how we can do is, the first approach is we can use DP. So what we will do is, here we will make the DP of the size of the length of the string 2D DP. 2D array, and what we will fill is we will fill this here we will fill like a substring that is starting with the character A and ending on the character A, substring that is starting from the character B ending with the character B, substring that is starting from the character C and ending with the character C respectively. So first thing is we can number them. This is 1, this is 2, this is 3, this is 4, this is 5. Okay, this is 5, this is 6 and this is 7. Similarly this is 1, 2, these are the character 4, 5, 6, 7. So here we will get the string that is starting from the character A ending at the character A. Here we will get string that is starting from the character A ending at the character B of length 2, string that is starting from the character A ending at the character C of length 3, that is A, B and C. String that is starting from the character A ending at character C of length 4. This is what we are going to store here. Over here also, of course, we are finding the substrings. So we cannot go like, so for here also, if we have to find the substring starting from B, we will go in this direction. We cannot use AB again. So that's why this cell is not of our use. We will just see the substring starting with the character B and ending with on the character B of string length 1. So let's fill it. Over here in this cell we will fill the string starting with the character A ending with the character A. What is that string? A. String that is starting with the character B ending with the character B. We will fill this grid diagonally. So here we will fill the length 1 string and then in the other diagonal we will fill length 2 string. I'll show you while traversing it. So in this cell we will fill the string which is starting with the character B and ending with the character B. That is only the single character B. Let me change the pen color. Let me take it yellow. Okay, so for every diagonal we'll have a different color. This is A, this is B. Over here this is not of our use, so just cross it. Over here we will fill string that is starting from the character C and ending with the character C. So a single length string, that is C. String that is starting from the character C ending with the character C of length 1, that is C. And again these cells are not of our use. String that is starting on B ending on B of character of length 1, B. String, these are not of our use again because we are seeing from this, so that's why these before cells are not of our use. String starting with C ending with C and of character 1, that is C itself. Again these cells are not useful to us, these will not be considered. Over here also these cells will not be used. So we will diagonally fill these strings of length 1, 2 and 3 respectively. So over here we will find this string starting with the character D, ending with the character D. So it will come over here. So this diagonal will contain all the string of length 1. Here this diagonal will contain all the string of length 2. This diagonal will contain all the strings of length 3. This diagonal will contain all the string possible of length 4. This will contain all the string of length 5. This will contain all the strings of length 6. This will contain all the strings of length 7. And this is how we are going to find whether it's a palindrome or not. Let's change color again for a minute. And now we will see the strings, substrings of length 2. So starting with A and ending with B. So this is AB. And starting with B, ending with C of 2 length, that is BC. Starting with C, ending with C of 2 length, that is CC. Starting with C, ending with B of 2 length, this is C, this is B. Starting with B, this is C. Starting with B, ending with C of 2 length, that is BC. And then last, starting with C, ending with D of the length 2, that is CD. So this diagonal contain the length 1 string substring, this diagonal contain the length 2 substrings. And let's change the color and find the other one. Length 3 is starting with the character A, ending on the character C is A, B and C. Starting with character B and ending on character C is B, C, C. Starting with character C and ending with character B is C, C, B. Starting with character C and ending on character C is C, B, C. Starting with character B and ending on D, that is this BCD of length 3. This will come. So B, C, D. So on third diagonal, that is this diagonal, we store the string which has the length 3. Now we will see for the string those who have length 4. So starting with character A, ending on C is this whole string A, B, C, C. So here it will come A, B, C, C. Over here it will come starting with B, ending with B of length 4, B, C, C, B. So B, C, C, B. This is C, Starting with character C, ending on character C of length 4 is C, C, B, C, because we can see from here. So it started from here, so C, C, B, C. So C, C, B, C. Starting with character C and ending on character D is C, B, C, D. So here it will come the 4 length string, that is C, B, C, D. And now over 5 length string, starting with character A, ending on character B is A, B, C, C, B. So let me change the pen color again, so it will be little more clear. It would be A, B, C. Okay, just give me a second. This is of length 5, so I am just removing it for now so that I can write it more clearly over here. So quickly change the pen color. Okay, so of length 5 is A, B, C, C, B. This is of length 5, and again starting with B, ending with C of length 5 is B, C, C, B, C. So here it will come B, C, C, B, C. Starting with character C, ending on D of length 5 is C, C, B, C, D. So it is C, C, B, C, D. Now we will come to the string of length 6. Quickly change the pen color. This time take some light pink or something. So starting with A, ending with C is this whole string A, B, C, C, B, C. So this is A, B, C, C. This is B, and here is one character C. Let me write it over here. This is A, B, C, C, B. And starting with character B, ending on the character D of length 6 is B, C, C, B, C, D. So this is B, C, C, B, C, 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 and this is D. This is of length 6. This diagonal of length 6, and the final is diagonal of length 7, which will actually tell us whether the whole string is palindrome or not. So this is A, B, C, C, B, C, D. This whole starting with character A and ending on D, that is A, B, C, C, B, C, D. So this is A, B, C, C, B, C, and D. Now we will find whether they are palindrome or not. So again I am repeating this. On this diagonal we will see the substring of length 1. On this diagonal we will see the substring of length 2. On this diagonal we will see substring of length 3 possible. On this diagonal we will see substring of length 4. On this diagonal we will have substring of length 5. On this diagonal we will have substring of length 6, and on this diagonal we have substring of length 7, and rest all this is not like useful to us. And then we will see whether they are palindrome or not. So every time make sure the single length character is always a palindrome. So A is palindrome in itself, whether we read it forward or backward, it is going to be A. This is also palindrome in itself. Single character C is also palindrome in itself. This character is also palindrome in itself. Single character is always palindrome in itself. So this whole diagonal is palindrome in itself. And then again, if we have two character, we can see whether A is equals to B or not. No. So A is not equals to B. This is not a palindrome. B is equals to this right side part. Is it equals to the left side part? No, it is not. So this is not a diagonal. Sorry, this is not a palindrome. CC, right part is equals to left part. Yes, so it is a palindrome. CB, right part is equals to left part. No, it is not. So it's not a palindrome. It's BC. So is the left part equals to right part? No, it's not a palindrome. These are not equal. Similarly, C and D are also not equal. So this is not the palindrome. When we are moving to the characters to the length 3 and itself, we will see its both extremities, whether they are equal or not. If the extremities are not equal, we will directly say it's not a palindrome. Then we will again check whether both the extremities are equal or not. No, they are not equal. This is not the palindrome. Again we will see extremities C and B are not equal. This is not the palindrome. This is not the palindrome. Directly cross C and C. Here extremities are equal. Then we will go diagonally downward and see whether B is a palindrome or not. It is a palindrome. So that means this whole string is the palindromic string. Because if we are reading it from the forward, it's CBC. If we are reading it from the backward, it's CBC. That is palindrome. Similarly, we will check extremities are equal. No, it is not. So we will directly say it's not the palindrome. Similarly, we will do for the length 4. A and C are equal. No, this is not the palindrome. B and B is equal. Yes, these are equal. So we will go diagonally downward. C and C is also palindrome. That means this whole string is a palindrome. We will go again see C and C. Is this a palindrome? Sorry, is this equal? Yeah, extremities are equal. So for this middle part, to check whether it's a palindrome or not, we will go downward. Is CB a palindrome? No, it's not a palindrome. That means this whole thing is not a palindrome. Similarly, we will check extremities. Is C and D equal? No, characters C and D are not equal, so this is not a palindrome. Now we will check for the length 5. A and B extremities are not equal. This is not a palindrome. B and C extremities are not equal. This is not the palindrome. C and D extremities are not equal. This is not the palindrome. Now we'll come to length 6. This is A and its extremities is C. Is A and C equal? No, this is not the palindrome. B and D extremities are not equal. This is not the palindrome. If extremities will be equal, then we have to check for the inner part, and for the inner part we will go downward direction, in the downward, diagonally downward, because this is stored diagonally downward when we have seen for the length less than this. But over here extremities are not equal, so that means this whole is not a palindrome. Now over here we will check A and D extremities are not equal. This is not the palindrome. As we have to return the count possible, like the palindromic count possible is, now we will check for all the cases those who are true. So like 1, 2, 3, 4, 5, 6, 7 in this diagonal, and then 8 in diagonal 2, and then in diagonal 3 we have this one, so this is 9, and then in diagonal 4 we have this, so this is 10, and rest we don't have. So the count total palindromic substring possible over here is 10. That's it. This is how it's very simple to solve this question using DP. And now let's code it up. So what is the first thing do we need? We need an integer which have this length of the string, and then we will make a boolean DP 2D of length n, and what we will do is we have to fill them diagonally. Like for diagonal of length 1, this is the diagonal of length 1, then this is of length 2, this is length 3, 4, 5, 6, 7, and so on. So to fill it diagonally, we will take a loop integer d. This is for diagonal, d is equals to 0, d is less than n, and d plus plus, and this is the loop which will traverse diagonally, that is 0 0. For length 1 we can go like 0 0, 1 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, and so on. So what we will do is, so we will take I is equals to 0 and j will be diagonal. What will be the the diagonal value, and it will go j less than dp dot length, we can say, or we can say dp dot length or n, and then I plus plus and j plus plus. And what we will do, we will see if g is equals to 0, then dp of I and j, whichever value is present, which will always be true, because this have the substring of length 1, which is always true. Else if g is equals to of length, g is 1, that is for length 2 I am talking about. For length 2 g is equals to 1, what we will do, we will check if s dot character at I is equals to s dot character at j, that is if both of these characters are equal, then we will put this as true, else we will mark it as false, that this is not the palindrome. And one more thing we need is the count, because that is what we have to return. So this is done, and now we will check for the other case, if the length is greater. This is for length greater than 2. What we will do is, first we will check if s dot character at I is equals to s dot character at j. If they are equal, and dp of I, we will go diagonally downward and see whether their inner part is also true, then at that place we will mark this as true, else it will be false. When we are out of this loop, what we will do, if our dp of I and j value is true, then we will just simply count plus plus, and after coming out of the for loop, we will just simply return count. And let's run this code. Okay, this was the comment for the length greater than 2. Okay, this is count plus plus. Okay. Okay, spelling error. Let's run it now. Okay, if okay, I'm so sorry. This is d is equals to 0 when diagonal is 0, when diagonal is 1, and so on. It's working. Let's submit it. Finally, we are done. It's submitted. Thank you. Time complexity we are looping it twice, so big O of n square, and space is also big O of n square because we are creating the 2D array. So we are done. Thank you.